You are probably wondering how to write 1 million, 1 billion, 1 trillion, quadrillion, quintillion, and so on. And asking yourself, is there any way we can write this number easily? Well, the answer is yes. Let me introduce to all of you the scientific notation. First, you might ask, who invented the scientific notation? Archimedes, the one who developed the scientific notation. Archimedes, considered as the father of mathematics for his significant contribution to the development of mathematics. He was a Greek mathematician, physicist, engineer, astronomer, and inventor. Second, what is scientific notation? Scientific notation was developed in order to easily represent numbers that are either very large or very small. It is also a shorthand way of writing numbers. Third, how to use scientific notation. In order to understand scientific notation, we need to know the 6 rules of significant figures. 1. All non-zero digits are significant, and these are the number from 1 to 9. The example of this is 987,654,321. And if you count them, there are total of 9 significant figures. 2. Zeros between non-zero digits are significant. The example of this is 707. And if you count them, there are total of 3 significant figures. 3. Leading zeros are never significant. Example 0.5, and if you count them, there are only total of 1 significant figures. 4. In a number with a decimal point, trailing zeros, those to the right of the last non-zero digit are significant. Example 0.500. If you count them, there are total of 3 significant figures. 5. In a number without a decimal point, a trailing zeros may be significant. These are the numbers from 2 to 9. Example is 200 or 900. If we count them, there are total of 3 significant figures. 6. In a number without a decimal point, a trailing zeros may not be significant. This is only for number 1. Example, 1000. If we count them, there are only 1 significant figures. After we know about significant figures, we can finally learn about scientific notation. Number in scientific notation are written with 3 parts: the coefficient, the base, and the power, wherein n is equal to 8 times 10 raised to b. Remember that if it's a whole number, then the decimal point is at the end. Second, apply the rule number 6. Wherein 1 is the only significant number. Third, count the numbers from point to point. By this, we can conclude that n is equal to 1 times 10 raised to 9. And remember that a coefficient is a number between 1 to 9 only. Now we are going to the different operation of scientific notation. In addition and subtraction, just normally add and subtract the coefficient, copy the base, and the power. In multiplication, just normally multiply the coefficient, copy the base, and add the power. While in division, just normally divide the coefficient, copy the base, and subtract the power. Again, the coefficient should be numbers between 1 to 9 only. Accuracy in calculation is important. That's why a lot of old mathematicians use this scientific notation to calculate even the largest amount of a number.